Hello everyone, I am Balaji Rao. Welcome to BR Max class. In this class, we are going to do one interesting problem from functions chapter. 80% of the students, they'll do mistake while solving this problem. This is easy problem, but you can do it easily when you are good in concepts. This is second question in interesting problems video series. If you want to see the earlier question, that playlist link I'll give in cards. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. This is the second interesting question. Please try this problem your own. 80% of the students, they'll get wrong answer while solving this problem. Try this problem your own. Once you got the right option, you check that whether it is correct or not with this solution. So what is the mistake that students generally will do? You see here, this g of x plus h of x is there. When they do g of x plus h of x, this comes like log m plus log n. Log m plus log n is log mn. So they'll think that yes, g of x plus h of x is f of x. So first option is the right option and they'll take that first option and they'll feel very happy. But unfortunately, that is wrong answer. Why? All those things I'll explain in this solution. In this question, if you observe all options, you see this function equal to this function. This function equal to this function. This function equal to this functions. Here, two functions equal. When we say two functions are equal, first thing, their domains must be equal, and second one, their functional values must be equal. To identify f of x is same as g of x plus h of x or f of x is same as g of x into h of x, I need domain of their functions. First, I will calculate domain of f of x. You observe this f of x, it is a logarithmic function. We know that logarithmic function is defined for positive real numbers only. So whatever expression is there here, this must be greater than 0. X minus 5 into 2 minus x. This must be greater than 0. Now, I need to find the x values which satisfies this inequality. To find those x values, I'll use wavy curve method. To use wavy curve method, this expression must be in the form of x minus a into x minus b. X minus a into x minus b. You observe this is not in the form of x minus b. So what I'll do, this complete inequality, I'll multiply with minus to get left hand side in the form of x minus a into x minus b. When I multiply with minus on both sides, that minus I'll multiply with this term. Okay, multiply with this term, what you will get? X minus 2. You know that for an inequality, if you multiply with a negative real number, inequality sign changes. Greater than changes to less than. As I am multiplying with minus on both sides, this greater than changes to less than. Minus 1 into 0 is 0 only. Now you observe this is in the form of x minus a into x minus b. Now by using wavy curve method, I can easily find what are the x values satisfies this inequality. You equate this term to 0, you will get x equal to 5. You equate this term to 0, you will get x equal to 2. 2, 5. You mark them as per the number line order. 2 comes first. 2, 5. Now, as per wavy curve method, in the rightmost corner, we'll keep plus and then we'll write alternate symbols. Now, I want x values for that this expression is less than 0. Less than 0 means negative. I need to look for negative sign. So, whenever I take x value in this interval, open interval 2, 5, then this inequality is less than 0. That is what wavy curve method says. So, whenever x is in this interval, open interval 2, 5, because it is strictly less than, whenever x value is in open interval 2, 5, then this expression is less than 0. So, what I got? I got domain of f of x. What is domain of f of x? So, I got domain of f of x. What is domain of f of x? Open interval 2, 5. Now, I need to calculate domain of g of x plus h of x, domain of g of x minus h of x, domain of g of x into h of x. You observe these three functions, f of x plus g of x, f of x minus g of x, f of x into g of x. You learned in the theory part, what is the domain of these functions? Suppose d1 is domain of f of x, d2 is domain of g of x. What is the domain of f of x plus g of x? That is d1 intersection d2. What is the domain of f of x minus g of x? This domain also d1 intersection d2. What is the domain of f of x into g of x? This domain also d1 intersection d2. In these three types of function, domain of these three functions is intersection of domain of f of x and domain of g of x. So, to calculate domain of g of x plus h of x, to calculate domain of g of x minus h of x, to calculate domain of g of x into h of x, I will calculate domain of g of x, domain of h of x First, domain of g of x. You observe this g of x. G of x is logarithmic function. We know that logarithmic function is defined for positive real numbers only. So here whatever the expression is there, that must be greater than 0. X minus 5 greater than 0. From this we can write that x is greater than 5. So I'll take domain of g of x as d1. What is the domain of this function? Greater than 5. Greater than 5 means 5 to infinity. So domain of g of x is open interval 5 to infinity. You observe this h of x, it is a logarithmic function. We know that logarithmic function is defined for positive real numbers only. So whatever the expression is there here, this must be greater than 0. So 2 minus x must be greater than 0. Now to get x value easily, I'll multiply with minus on both sides. Multiply with minus, this 2 minus x will become x minus 2. And you know that for an inequality, if we multiply with a negative real number, inequality sign changes. This greater than changes to less than 0. From this I can write that x is less than 2. So what is the domain of h of x? All x values which are less than 2. I'll take domain of h of x as d2. What is d2? Open interval minus infinity to 2. That means all x values are less than 2. Okay. I know that domain of g of x plus h of x, domain of g of x minus h of x, domain of g of x into h of x is d1 intersection d2. I will calculate d1 intersection d2. I considered a number line. In that, what is d1? 5 to infinity. See, this is d1. 5 to infinity. This is d1. Okay. And d2 is minus infinity to 2. So this is minus infinity to 2. This is d1, this is d2. What is intersection? What are the, see, this is first set, this is second set. Is there any element common in d1 and d2? They are disjoint. No element common in d1 and d2. So d1 intersection d2 is what? D1 intersection d2 is null set. So what is domain of g of x plus h of x? Null set. What is domain of g of x minus h of x? Null set. What is the domain of g of x into h of x? Null set. Okay, now I will come to the first option. Two functions, this is one function, this is another function. When we say two functions are equal, when their domains are equal and their functional values are equal. What is domain of f of x? You observe here, domain of f of x is open interval 2, 5. What is the domain of g of x plus h of x? Null set. These two functions are equal means their domains must be equal. But this domain is open interval 2, 5. This domain is null set. From that, we can easily say that this doesn't holds good. These two functions are not equal. If two functions are equal, their domains must be equal. I hope you are understanding. Similarly, come to the second option. Domain of f of x is open interval 2, 5. What is domain of g of x minus h of x? Domain of g of x minus h of x is null set. These two functions are equals means their domains must be equal. But this domain is open interval 2, 5. This domain is null set. That's why this is wrong option. Again, come to this domain. F of x domain is open interval 2, 5. Domain of g of x into h of x is null set. Two functions are equal means their domains must be equal, but their domains are not equal, so this is also wrong option. Obviously, what is the right option? None of these is the right option. So many students by mistake they'll choose this first option, but that is wrong option. This is actually very easy. If you know the definition of equal functions, then you can do this very easily. I hope you understand this class. If you like this problem, please drop a like for this video and share this video with your friends. If you want more problems like this, please comment below. Thanks for watching this video. Have a great day. Take care. Bye-bye.